I am Nikhil Shinde. Our problem is word count application using MapReduce model. Our group member is Saurabh Patil, me, and Harish Dubey. So let's begin with the introduction. So what is exactly word count? It is basically simple task of counting how many times each words appear in a given set of documents. For example, if we take sentence, the cat sat on the mat, the word the appears twice. Now, you might be thinking this sounds too simple, right? But it's actually very important in the world of data processing. Word count is the foundation of text analysis used in applications like search engines, data mining, event trends, analysis on social media. That's why it is often called hello world of big data. It is easy to understand, but it becomes very challenging when you deal with a massive amount of data. Let's let's look at the problem statement. The main challenges here is big data. What if we had terabytes of text? For example, the entire Wikipedia. Processing such a huge data on a single computer would be extremely slow or sometimes not even possible. Traditionally, one computer processes all the data sequentially. This is not efficient, the slow and prone to failure if something goes wrong. So instead of using one powerful machine, we can use distributed approach with the MapReduce. MapReduce breaks the word into smaller parts and distributes them across many computers in a cluster. This way becomes much faster and more reliable. Overview of MapReduce model. Now let's understand what MapReduce actually is. MapReduce is a programming model designed to produce large datasets in a parallel across distributed cluster of computer. The key idea here is divide and conquer. We divide tasks into smaller parts, process them separately, then combine the result. The main it mainly consists of two important functions. MapReduce function, which processes us the input data and converts it into key value pairs. For example, word count problem. It takes the word as a key as a assign each one up as a count of one. The reduce function, which then merges or the aggregate of the uh, intermediate values associated with the same key. In this case, summing up the count for each word. So together map and reduce make it possible to handle massive data set efficiently. So how working of MapReduce happen? So first thing we split it. Second we do mapping, then shuffling, then reducing. Word count example. So now let's understand this with a simple example. Suppose our input consists of two small sentences, hello world and hello data. First, during the splitting step, these are divided into two parts, split 1 and split 2. Split 1 contains hello world, split 2 contains hello data. Next, the mapping stage process is each split. The mapper produces hello 1 and word 1. Mapper 2 produces hello 1 and the data 2. So data 1. Then comes shuffling and sorting, where the output with the same key are grouped together. So we get data 1, hello 1, comma 1 and word 1. Finally, the reducer sums the counts for the each data. So for data, total count is 1. For hello, total count is 2. For world, total count is 1. So this is how MapReduce performs word counting step by step. Pseudo algorithm. Now let's see how this looks in a pseudo form. Here is the MapReduce function for each word in the document. It simply emits the word 1. Then reducer function takes all the values of the same word which are list of 1 and sum of them. Finally, it emits the word along with the total count. Even though the logic looks simple, the power of MapReduce comes from the fact that that function is running in parallel across hundreds or even thousands of computers. So this is small pseudocode can handle massive data set just by scaling across machines. Advantages of MapReduce. Scalability easily scales by adding more machines to the cluster. Fault tolerance. If one machine fails, work is redistributed to others. Parallel processing. Many tasks run simultaneously, saving time. Simplicity. Developers only need to write map and reduce logic. Conclusion. The, the word count application perfectly demonstrates the power of MapReduce. It breaks the complex problem for large dataset into simple parallel tasks. This model is the core processing engine behind Hadoop, a leading data framework. Key takeaways: MapReduce enables efficient distributed processing of massive data across thousands of computers. These are our references. Uh, so thank you.